The topic is order of operations. The objectives in this topic are simplify expressions by using the order of operations, evaluate an algebraic expression, and find the average of a list of numbers. So to review order of operations, this isn't new, but now that we know integers, we're going to use integers within the order of operations simplifications. First, we perform operations that are within parentheses, brackets, or other grouping symbols, such as fraction bars, starting with the innermost set. Then evaluate any expressions with exponents. Then multiply or divide in order from left to right. Finally, add or subtract in order from left to right. PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division as we come to it from left to right, addition or subtraction as we come to it in order from left to right. And a helpful hint, since we're going to be dealing with negative numbers, simplifying expressions with exponents, parentheses, will make an important difference. For instance, -5 squared with parentheses and -5 squared without parentheses do not mean the same thing. With parentheses, that means -5 times -5, which would be +25. But without parentheses, it would mean the opposite of 5 times 5, which would be the opposite of 25, -25. So only with parentheses is the entire -5 squared.
Okay, so let's simplify. Fraction bar is 2 problems. The bottom is done. It's just a -4. On the top, we have -8 times 3. Remember, different signs when we multiply is a negative number. -8 times 3 would be -24. Finishing this off, negative divided by negative is positive. 24 divided by 4 is 6. So this would be +6. Go ahead and try this one. 24 plus 19 plus -3 squared. And pay attention to where those parentheses are and what that means when you're squaring. If you said 34, you are wrong. If you have 34, you're not done. Go ahead and pause to try this again or to finish, because here come the spoilers. So we have to do exponents first. -3 squared with the negative inside the parentheses means -3 times -3, which is what? +9. So this is 24 plus 19 plus 9, not -9. If you did -9, you ended up with 34 and got the wrong answer. Instead, we have to do 24 plus 19 is 43. Plus 9, whoops, is 52. So 3 more examples. I'd like you to try all 3 of these. Get them all on the screen at the same time. There we go. So 1, 2, 3. We have 4 times the quantity 5 minus 2 plus 4 squared. Then we have negative 5 squared plus negative 7 squared. This time the negative 7 is in parentheses. Minus 1 cubed. Negative 5 squared plus negative 7 squared minus 1 cubed. And then over here, we have 4 times the quantity 6 minus 9 plus negative 6 minus radical 49. So go ahead and do these 3. And pause, because I'm going to start the answers right now, starting with the top. Okay, first, inside parentheses, 5 minus 2 is 3. So 4 times 3 plus 4 squared. The exponents. 4 squared is 4 times 4, that's 16. The multiplication, 4 times 3 is 12. And then finally, 12 plus 16 is 28. Next, negative 5 squared without the parentheses is negative 1 times 5 squared. So this is negative 25, not positive because it's not in parentheses. Then plus negative 7 squared. This is in parentheses, so negative 7 times negative 7 is positive 49. Minus 1 cubed is 1 times 1 times 1, which is 1. So we have negative 25 plus 49, which is the same as 49 minus 25. That's going to be positive 24. We're adding 2 numbers. Their absolute values. We're adding 2 numbers with different signs. The absolute values are 49 and 25, which gives us the 24. The larger absolute value was 49. 49 came from a positive number, which is why it's positive 24. Minus 1 gives us an answer of 23. Finally, for these sorts of problems, working in parentheses gives us 6 minus 9 is negative 3 there. Plus negative 6, nothing to work on. Minus the square root of 49 is 7. 4 times negative 3 is negative 12. Plus negative 6 minus 7. We have to do addition and subtraction from left to right as we come to it. We're adding 2 numbers. They have the same sign. Their absolute values are 12 and 6. Add those together, we get 18. But they're both negative numbers, so it's negative 18. Negative 12 plus negative 6 is negative 18. Minus 7. We're getting more negative. We can also think of this as negative 18 plus negative 7. Either way, we're going to get an answer of negative 25. 18 plus 7 is 25. The numbers we're adding are both negative, so it's a negative 25.
Next up, negative 3 times square brackets, negative 5 plus 2 times parentheses, negative 4 plus 5, close parentheses, close square brackets, minus 6. So we have grouping symbols within grouping symbols, parentheses inside of square brackets. We go to the innermost set. So we start with inside the parentheses, we start with that -4 plus 5. And -4 plus 5 is +1. Now the grouping symbols we have are just the square brackets. We work inside of that. We have -5 plus 2 times 1. We have addition. We have multiplication. Order of operations says multiplication comes first. So 2 times 1 is 2. All that we have left in the square brackets now is -5 plus 2. -5 plus 2 is -3. We can change those square brackets to parentheses at any time. We have multiplication. We have subtraction. Multiplication comes first. -3 times -3 is +9. +9 minus 6 is +3. Evaluate 9x squared plus 12 for x equals -3. Notice that it's the entire x that is squared. X is a -3, so it's going to be the entire -3 that's squared. So when we make our replacement, we have to be sure to use parentheses, because the entire -3 has to be squared just like the entire x was squared. -3 squared is +9. We have multiplication. We have addition. Multiplication would come first. 9 times 9 is 81. 81 times 12, sorry, 81 plus 12 is 93. This graph shows some monthly normal temperatures for a city in Alaska. Use this graph to find the average of the temperatures for the months January through May. Recall, to find an average, we add up the values and we divide by the number of values. Add them up and divide by how many there are. We are looking for January through May. We can ignore October, November, and December. We're just looking here. That's 1, 2, 3, 4, 5 values. We're going to add them up and we're going to divide by 5. -14 plus -16 plus -14 plus -1 plus 20. Divide by 5. -14 plus -16 is -30. Plus -14 would be -44. Plus -1 would be -45. Plus 20 brings us up to -25. And then -25 divided by 5 is -5. So the average of the temperatures from January through May is -5 degrees Fahrenheit. And that's it for this topic. The topic is solving equations, the addition and multiplication properties. The objectives in this topic are: identify solutions of equations, use the addition property of equality to solve equations, use the multiplication property of equality to solve equations. So, a bit of a review. Statements like 5 plus 2 equals 7 are called equations. Anything with an equal sign. An equation is the form expression equals expression. And if we labeled an equation, the equal sign would be in the middle. Then we'd have the left side and the right side. The equation is saying that these two sides are equal to each other, that they have the same value. When an equation contains a variable, deciding which values of the variable make an equation a true statement is called solving an equation for the variable. So up until now, we've just been looking and seeing, are things solutions? We haven't been asked to find the solution. And again, a solution is a value for the variable that makes the equation a true statement. So we've done things like this before. Determine whether negative 2 is a solution of 2y plus 1 equals negative 3. We would take our negative 2 and we would plug it in, replace y. So instead of 2y plus 1, we'd have 2 times negative 2 plus 1. We want to know if that's equal to negative 3. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So since negative 3 equals negative 3 is a true statement, negative 2 is a solution of the equation. Now solving. To solving, we have to solving. To solve, we have to use properties of equality to write simpler equations, all equivalent to the original equation, until the final equation has the form x equals number or number equals x. Equivalent equations have the same solution, and the word number above represents the solution of the original equation. This will make sense, I promise. The addition property of equality. I'm going to say it in its technical form, and then I'm going to simplify it for you. Let A, B, and C represent numbers. If A equals B, then A plus C equals B plus C, and A minus C equals B minus C. So, in other words, the same number can be added to both sides or subtracted from both sides of an equation without changing the solution of the equation. That is extremely powerful when it comes to solving. So let's take a look at x minus 4 equals 3. We want to solve this for x. Now you might be able to look at that and say, hey, 7. 7 minus 4 is 3. X equals 7. But that's not solving. Solving is following a specific process. That process is going to be undo things to get the x by itself. And then whatever we do on one side, we have to do on the other. So here we have x minus 4. We want to get the x by itself. We need to undo minus 4. The opposite of minus is plus. So we plus 4. Whatever we do to one side, we do to the other. Plus 4 on both sides gives us x equals 7. That's how we need to get x equals 7. So again, breaking it down, to solve for x, we need to rewrite the equation in the form x equals number. To do so, we add 4 to both sides of the equation. So instead of x minus 4 equals 3, we add 4 to both sides and get x minus 4 plus 4 equals 3 plus 4. Just like an old-fashioned scale that you see justices blind holding outside of a courthouse. The two sides need to stay in balance. If we add 4 to one side, we have to add 4 to the other side. The minus 4 plus 4 on the left cancel each other out, leaving us with just x. And then on the right, 3 plus 4 gives us 7. We can always check to see if we have the right answer. To check, we replace x with 7 in the original equation. Instead of x minus 4 equals 3, we want to see if 7 minus 4 equals 3. It does. It's true. 7 is the solution. Now remember, when you're checking, you have to check in the original equation, not one of the equations that we get along the way. And we can get the variable alone on either side of the equation. X equals 3 and 3 equals x. Both of those are saying the solution is 3. So here, negative 2 equals z plus 8. The z is on the right. So this one, we're going to get number equals z. And that's okay. It doesn't have to be z equals number. They mean the same thing. To get the z by itself, we want to get rid of plus 8. We undo plus 8 with minus 8. So we need to subtract 8 from both sides. Negative 2 minus 8 equals z plus 8 minus 8. Negative 2 minus 8 is negative 10. Plus 8 minus 8, those cancel away. Number plus its opposite. So negative 10 equals z. And most of the time, we're not going to go through the steps of checking the equation, checking the solution to see if it works. The check is always left to the student in most cases. So feel free to check negative 10 in that original equation and make sure that it works. We have a multiplication property of equality. In the addition property, we were able to add or subtract the same thing from both sides without changing the value. This property tells us we could multiply or divide both sides by the same thing and not change the value. So with 4x equals 8, that's 4 times x. We need to undo times. We do that with dividing. Divide both sides by 4. 4x over 4 equals 8 over 4. 4 divided by 4 is 1. 1 times x is x. 8 divided by 4 is 2. So x equals 2. When I did this, 4 divided by 4 is 1. 1 times x is x. That's the whole point of dividing both sides by 4. We want to undo the 4 that was in front of the x. We want to just have one x, a single x. And one x is always written as just an x. Likewise, if we have just an x, we can always assume that there's an invisible 1 right in front of it. Let's check this value, take our 2, plug it into the original equation. 8 equals 8. It checks. The solution is 2. X divided by negative 4 equals 7. This time we want to undo dividing by negative 4, so we're going to multiply both sides by negative 4. The negative 4 divided by negative 4 on the left leave us with positive 1x, or just x. 7 times negative 4 is negative 28. And that is it for this topic. The topic is simplifying algebraic expressions. And the objectives in this topic are: use properties of numbers to combine like terms, use properties of numbers to multiply expressions, simplify expressions by multiplying and then combining like terms, and find the perimeter and area of figures. A term that is only a number is called a constant term, or simply a constant. A term that contains a variable is called a variable term. So x plus 3, the constant term, would be 3. 3y squared plus negative 4y plus 2, the constant term would be 2. The sign in front goes with it. So that is a plus 3 from the left. That is a plus 2 from the right. The variable terms would be x, 3y squared, and negative 4y. The terms that have variables in them. Previously, you might have heard me talking about the number in front of the variable. In front of this x, we can imagine that there is a 1. 1x is a single x. 1 times x is x because anything times 1 is itself. We always write 1x as just x, but we know there's an imaginary 1 there. There's a 3 in front of this y squared. There's a -4 in front of this y. The number factor of a variable term is called the numerical coefficient. And like I said, the numerical coefficient of 1 is usually not written. So 5x has a coefficient of 5. X is 1x. The understood coefficient is 1. -7y, the coefficient is -7. The sign comes with it. The sign is part of the coefficient. The coefficient of 3y squared is 3. Now, terms that are exactly the same, except they might have different numerical coefficients, those are called like terms. So the same variables raised to the same powers are like terms. 3x and 2x, they both just have x to the first power. -6y, 2y, and y, they all just have y to the first power. -3 and 4, they're constants. They both don't have variables. Some examples of unlike terms would be 5x and x squared. They are both x's, but they're to different powers, so they are not like terms. 7x and 7y. The fact that the 7s are the same have nothing to do with it. The variables are different, x and y, so those are not like terms. 5y and 5, again, the common 5 has nothing to do with anything. 1 is a variable term, 1 is a constant term. They can't be like terms. 6a and ab. They both have a, but just like x and x squared weren't the same thing, a and ab aren't the same thing. B is an extra variable that one has that the other doesn't. They cannot be like terms. The order of the variables does not have to be the same. So for instance, 2ab squared and -5b squared a, those actually would be like terms. They both have a, they both have b squared. The order doesn't matter because order doesn't matter when we multiply. Let's review the distributive property. I warned you that once we get to x's, the distributive property would be important, and we would need to know that AC plus BC, for instance, is A plus B times C. AC minus BC is A minus B times C. And that goes both ways. If we have A plus B and we're multiplying by C, A times C plus B times C would be true. If we have A minus B and that's times C, A times C minus B times C would be true. Previously, we saw this as A times B plus C and A times B minus C. But the thing that gets multiplied through can also be on the right side. It doesn't have to be on the left. We were used to eliminating the parentheses, but in this form, we're kind of writing it with parentheses. And there's going to be a point to that. You're going to see that. This example should clear up why this form of the distributive property is going to be useful for us. It says that 7x plus 5x would be 7 plus 5 times x. And we know 7 plus 5 is 12. So 12 times x, 12x. That's how we know that 7x plus 5x is 12x. The distributive property is working in the background. I like to simplify this, though. Instead of thinking about it like the distributive property, I like to think of them as things. For instance, apples. 7 apples plus 5 apples is 12 apples. But instead of apples, we have x's. 7 x's plus 5 x's is 12 x's. This is an example of combining like terms. And we say that an algebraic expression is simplified when all like terms have been combined. So let's practice and combine like terms. 8y plus 4y, 8 of them plus 4 of them is 12 of them. In B, y minus 6, y is the same as 1y. So 1 of them minus 6 of them is negative 5 of them, negative 5y. In C, we can't do anything with that minus 3, but we can combine the x squareds. 4 of them plus 6 of them is 10 of them. 10x squared minus 3. Let's recall we had some addition and multiplication properties. We had the commutative properties that say we could add or multiply in any order without changing the value. The commutative properties were the properties where we pick up and move. We change the order. So a plus b equals b plus a, and a times b equals b times a. The commutative property is the ABA property. Meanwhile, we have the associative properties that say that the groupings can be changed. We can put parentheses around different pairs of addition and different pairs of multiplication and still get the same answer. So if we're adding a plus b plus c, it doesn't matter if we add a plus b first or if we add b plus c first. When we add that third thing onto the sum at the end, we will get the same answer. Same with multiplication. A times b times c. It doesn't matter if we do a times b first or if we do b times c first. When we multiply by that third thing, we're going to end up with the same answer either way. So some examples. 4 plus 3 equals 3 plus 4 would be the commutative property of addition. The order has changed. The numbers have moved. They've commuted. 6 times 9 equals 9 times 6 is an example of the commutative property of multiplication. Again, the numbers moved. They commuted. Hopefully they didn't get stuck in traffic. The associative property of addition, an example of that would be 3 plus 5 plus 2, where on one side we add the 3 plus 5 together first, and on the other side we add the 5 plus 2 together first. Either way, 8 plus 2 is the same as 3 plus 7. 10 equals 10. 7 times 1 times 8. Doesn't matter if we do the 7 times 1 first or the 1 times 8 first. 7 times 8 is the same as 7 times 8. That's an example of the associative property of multiplication. Why did we review these? Well, first, let's start by writing this as all addition. So instead of minus 3, that's plus a negative 3. Subtracting is adding the opposite. Now we have 4 things being added, and we can add them in any order. So let's change the order. Let's put the y's next to each other and the constants next to each other. Then 6y plus 4y, 6 of them plus 4 of them, is 10 of them. And 5 plus negative 3 is positive 2. So this simplifies to 10y plus 2. In A, we don't have to move anything around. The y's are already next to each other. 6 of them plus 12 of them is 18 of them. So 18y minus 6. In B, we can move things around. And to be technical, we can only do that when everything's addition. So the first thing we'll do is add the opposite, turning that minus 5 into plus a negative 5. Then move them around so that the y's are next to each other and the constants are next to each other. 7y plus y. 7 of them plus 1 of them is 8 of them, 8y. And then negative 5 plus 8 is 3, 8y plus 3. Negative 7y plus 2 minus 2y minus 9x plus 12 minus x. They're getting larger. They're getting more complicated. There's more to do. We see that we have some y's, we have some x's, we have some constants, and we need to combine the y's. We need to combine the x's. We need to combine the constants. If we're going to start moving things around, a good idea is to start by writing everything as addition. So negative 7y plus 2 plus negative 2y plus negative 9x plus 12 plus negative x. And then move the things around so that the y's are next to each other, the x's are next to each other, and the constants are next to each other. Then we combine. Let's do x's first, just because x comes before y, alphabetically. Negative 9x plus negative x. Negative 9 plus negative 1 is negative 10. So negative 10x. And then we have negative 7y plus negative 2y. That's negative 9y. Finally, 2 plus 12 is 14. And we wouldn't write it negative 10x plus negative 9y. We would simplify that because plus a negative is the definition of subtraction. So negative 10x minus 9y plus 14 is how we would write the final answer. We could also use the distributive property to multiply expressions. So this is the form of the distributive property that we're most familiar with coming into this topic. If we had 2 times 5 plus x, that's 2 times 5 plus 2 times x. And we can simplify that to 10 plus 2x. If we have 2 times 5 minus x, that's 2 times 5 minus 2 times x, which can be simplified as 10 minus 2x. We don't need to use the distributive property unless we are adding or subtracting inside the parentheses. So in these two, this is 5 times y. This is 9 times x. We're not adding or subtracting, so we're not distributing. Instead, we would consider the associative property. We can't do 5 times y, but if we change where the parentheses are, we can do 5 times 5. 5 times 5 is 25, so 25y. Likewise, we can't do 9 times x because we don't know what x is, but we can change where the parentheses are, and we can do negative 8 times 9. That's negative 72. Negative 72 times x. But we can't do that moving the parentheses trick when we're adding or subtracting inside. Remember, the associative property is only good if they're all multiplication or if they're all addition. Here, we can't add x plus 5. We don't know what x is, but we still need to multiply. We still need to get rid of the parentheses. We do that with the distributive property. 6 times x is 6x. 6 times positive 5 is positive 30. So we express that as plus 30. We've done it. We've successfully distributed. We've gotten rid of the parentheses. We have multiplied. We have an equivalent expression. Negative 5 times 4a plus 3. Again, we can't add 4a and 3. We don't know what a is. We still need to be able to multiply. We still need to be able to get rid of the parentheses. We use the distributive property. Negative 5 times positive 4a. We can do that. That's negative 20a. Negative 5 times positive 3. That's negative 15 or plus negative 15. Negative 20a minus 15 is how we simplify that. Personally, I like to skip that second addition step. You saw how I said it. I said negative 5 times positive 4a is negative 20a. Negative 5 times positive 3 is negative 15. I jump straight to writing it as minus 15. But if you need extra steps, that is perfectly fine. So to simplify expressions, our first step is to use the distributive property first to multiply and then combine any like terms. So to simplify, 3 times the quantity 5 plus x minus 17. First, we get rid of the parentheses by distributing, by multiplying, and then we combine any like terms. 3 times 5 plus 3 times x. That's 15 plus 3 times x. 15 plus 3x. Plus negative 17. We're bringing that down. Or minus 17, however you have it. Combine like terms. 15 plus negative 17 is negative 2. So 3x plus negative 2. We write that as 3x minus 2. Just a note, that 3 does not get distributed to the negative 17 because that negative 17 is not inside the parentheses. We stop distributing when we hit the end of the parentheses. Next up, negative 7 times the quantity x minus 1 plus 5 times the quantity 2x plus 3. First step, use the distributive property to remove the parentheses. We multiply. We take what we have and we distribute the negative 7 to the x and to the negative 1. Negative 7 times x plus negative 7 times negative 1. Then we distribute the positive 5 through its parentheses. Plus 5 times 2x plus 5 times 3. Now we have some things we can simplify. Negative 7 times x is negative 7x. Negative 7 times negative 1 is positive 7. Plus positive 7 is just plus 7. Positive 5 times 2x, that's a positive 10x, so plus 10x. Positive 5 times 3, that's positive 15, that's plus 15. We have some like terms. Negative 7x's plus 10x's is 3x's. And then positive 7 plus 15 is positive 22 plus 22. Let's revisit the idea of perimeter. Recall perimeter is adding all the sides. Here we have a triangle, and the sides are given in terms of z. 3z, 9z, and 7z. We want to add the three sides. We need the distance around the figure. So pick a starting point, and we add 3z plus 7z plus 9z. 3 plus 7 is 10 of them. 10 plus 9 is 19 of them. 19 of what? 19 of z, 19z. And we say that it's 19z feet because those were the units of the problem. And perimeter is a distance, so it needs to have units. Finally, let's revisit area. Area of a rectangle was length times width. Here, one of those is given as 3 meters. The other is given as 2x minus 5 meters. So when we multiply those, length times width, we get 3 times 2x minus 5. We need to distribute. 3 times 2x is 6x. 3 times negative 5 is negative 15, so 6x minus 15. And recall that the units here are square meters, because meters times meters are square meters. Remember, area is the stuff inside. And the stuff inside are how many squares that are 1 meter by 1 meter can we fit in there. And that is it for this topic. The topic is solving equations, review of addition and multiplication properties. The objectives in this topic: use the addition property or the multiplication property to solve equations, use both properties to solve equations, and translate word phrases to mathematical expressions. So once again, statements like 5 plus 2 equals 7 are called equations. An equation is of the form expression equals expression, and we can label it as the left side of the equation, the equal sign, and the right side of the equation. If A, excuse me, if A equals B, then A plus C equals B plus C, and A minus C equals B minus C. In other words, we can add the same thing to both sides of an equation, or we can subtract both things, the same thing from both sides of an equation without changing its value. Likewise, we could multiply both sides of an equation by something or divide both sides of an equation by something and not change its value. So if A equals B, AC equals BC. A over C equals B over C. We're going to do some examples like we did before with the addition and multiplication properties, although now we're going to have the extra step of making sure there are no like terms to combine first before we use the property. Here we have x plus 6 equals 1 minus 3. On the left side of the equation, we have x plus 6. There's nothing we can do to that. On the right side of the equation, we have 1 minus 3. We can simplify that, so let's simplify the right side. 1 minus 3 is negative 2. X plus 6 equals negative 2. Now we can apply our properties of equality to get the x by itself on one side and everything else on the other. So we have x plus 6. We want to get the x by itself. We need to undo adding 6. We do that with its opposite, subtracting 6. So let's subtract 6 from both sides. X plus 6 minus 6 on the left, negative 2 minus 6 on the right. The plus 6 minus 6 cancel each other out on the left, just leaving us with x. On the right, negative 2 minus 6 is negative 8. We can check our answer in the original equation to see if we're right. Instead of x plus 6, we'll go negative 8 plus 6 equals 1 minus 3. That gives us negative 2 equals negative 2, which is true. The solution checks. The solution is negative 8. Another one, 10 equals 2m minus 4m. Let's look at the left side and let's look at the right side. Make sure there isn't anything to simplify first, that there aren't any like terms that we can combine. Looking at the left side, we have 10. Can't do anything to 10. 10 is 10. On the right side, we have 2m minus 4m. We can combine like terms. 2 of them minus 4 of them is negative 2 of them. So 2m minus 4m is negative 2m. Now we have 10 equals negative 2 times m. We need to get the m by itself. We'll undo times negative 2 with its opposite divided by negative 2. And whatever we do on one side, we have to do on the other. So both sides get divided by negative 2. On the right, the negative 2's cancel out, just leaving us with m. On the left, 10 divided by negative 2, positive divided by negative is negative. 10 divided by 2 is 5, so negative 5 equals m. That's the same as saying m equals negative 5. Remember, it doesn't matter which side of the equal sign our variable is on. If we go to check, we're going to plug negative 5 in for m in the original equation. So we have 10 equals 2 times negative 5 minus 4 times negative 5. 2 times negative 5 is negative 10. Negative 4 times negative 5 is positive 20. Negative 10 plus 20 is 10. So 10 equals 10. That's true. The solution checks. The solution is negative 5. Another one. Don't just jump straight to undoing division with multiplication. We have to examine both sides first to see if there's anything that simplifies. Looking at the left, negative 8 plus 6 is negative 2. We can simplify the left side and get negative 2. Then on the right, we need to undo dividing by 3. We do that with multiplying by 3 on both sides. 3 times negative 2 is negative 6. So negative 6 equals A. Plus 3 or times 3 divided by 3, those cancel each other out, just leaving us with A. If we check, take that negative 6, plug it in for A. Negative 6 divided by 3 is negative 2. Negative 2 equals negative 2 is true. The solution checks. The solution is negative 6. Let's kick it up a notch. Negative 6y minus 1 plus 7y equals 17 plus 2. Here we're able to simplify each side of the equation. We can do something on the left and we can do something on the right. On the left, let's just pick up and move that 7y so that it's next to the negative 6y. On the right, let's do 17 plus 2 is 19. Now, negative 6 plus 7 is positive 1. That means that negative 6y plus 7y is positive 1. Negative 6 of them plus 7 of them is 1 of them. And 1y is just y. So we have y minus 1 equals 19. This we can solve by adding 1 to both sides. To get the y by itself, we undo -1 with +1. Whatever we do on one side, we do to the other. We get 19 plus 1 is 20. Y equals 20. If you want to check that, I leave that to you. Next up, -4 minus 10 equals 4y minus 5y. Once again, we can do something to both sides of the equation. On the left, -4 minus 10 is -14. On the right, 4y minus 5y is -1y, or -y. 4 minus 5 is -1, so 4 of them minus 5 of them is -1 of them. Just minus y. Now, normally we want positive y equals. We have negative y equals. We can divide both sides by -1. And that gives us positive 14 equals y. In other words, the opposite of y was -14. That means y is positive 14. (13x) equals 4 times the quantity 3x minus 1. We can simplify the right side. We know how to multiply to get rid of parentheses. 4 times 3x is 12x. 4 times -1 is -4. That simplifies the right side to 12x minus 4. Now, we have a complication. We have x's on both sides. We can't get the x by itself until they're all on one side. What tools do we have at our disposal to get rid of a positive 12x? Well, we can subtract 12x from both sides. 13x minus 12x on the left. On the right, 12x minus 4 minus 12x. 13 of them minus 12 of them is one of them. So that's just x equals on the left. On the right, 12x minus 12x is 0. So we're just left with the -4. X equals -4. So that was interesting. 5y plus 2 equals 17. In order to get the y by itself, we need to get the 5y by itself. We need to get the term with the y in it by itself. We need to undo adding 2. We do that with subtracting 2. Whatever we do on one side, we do to the other, so subtract 2 from both sides. That leaves us with the 5y on the left, and on the right, 17 minus 2 is 15. Now, to get the y by itself, we need to undo multiplying by 5. We do that by dividing both sides by 5. We've just used both properties in the same equation, the one where we add and subtract and the one where we multiply and divide. This leaves us with y equals positive 3. So we can kind of get into the groove of there being a certain thing we do in every situation. Simplify both sides. If there are parentheses, we need to distribute to get rid of them. Combine like terms on the left, combine like terms on the right. Use the addition property of equality to make sure all of our x's are on one side and there's none hanging out on the other. Use the addition property to get everything where it needs to be on which side of the equation. Simplify. And then use the multiplication property to divide by whatever we need to divide by to get the x by itself. So how can we apply that here? First, simplify each side of the equation. So we can distribute that -4 on the left, get -4x minus 8. And then on the right, 2 minus 10 is -8. Combine like terms on the left. Negative 8 minus 60 is negative 68. Now keep the x's on the left. Add 68 to both sides to get all the numbers on the right. In other words, to get the x by itself, we need to get the negative 4x by itself. We need to get rid of subtracting 68. We do that with its opposite, adding 68. Whatever we do to one side, we have to do to the other. A number plus its opposite on the left is 0. That just leaves us with negative 4x equals negative 8 plus 68 is positive 60. Finally, divide both sides by negative 4 to undo multiplying by negative 4. So multiply by negative 4, get rid of that by dividing by negative 4. Whatever we do on one side, we do to the other. 60 divided by negative 4 is negative 15. We're left with x is equal to negative 15. Before we finish off this topic, a quick review of our word problem words, our addition indicators, our subtraction indicators, our multiplication indicators, and our division indicators. This is not the first time we're coming across these, which must mean we're about to write phrases as algebraic expressions. We're going to use x to represent a number. So the sum of negative 3 and a number would be adding negative 3 and a number, adding negative 3 and x, negative 3 plus x. Negative 5 decreased by a number. Well, if we're decreasing something by a number, we are subtracting a number from it. Starting with negative 5 and subtracting x. Negative 5 minus x. C is very straightforward. 3 times a number is 3 times x, or 3x. D, a number subtracted from 83. Don't do x minus 83. If we're subtracting from 83, we're starting with 83. We're subtracting a number from that. 83 minus x. And the quotient of a number and negative 4. The quotient of means division. Division, the order matters. First divided by second. A number divided by negative 4. X divided by negative 4. And a note, if we have a negative on the bottom, we can write the whole thing as a negative because that is a positive x divided by a negative 4. And positive divided by negative is negative overall. We can write that as negative x over 4. Let's do some more complicated ones. Still using x to represent a number. The product of 5 and a number decreased by 25. The product of 5 and a number would be 5 times the number, 5 times x, or 5x. And then we're decreasing that by 25. We're subtracting 25. 5x minus 25. B, twice the sum of a number and 3. Twice the sum means 2 times the sum. The sum is the result of an addition problem. The sum of what? A number and 3. So x plus 3. Twice that whole thing means twice 2 times parentheses, x plus 3. Why did this one have parentheses but the last one didn't? Well, in the last one, we were taking the product and then subtracting 25 from that. Multiplication and then subtraction. Here, we're taking the sum and we're multiplying by the sum. The sum is the entire x plus 3. So the parentheses group that together, representing the sum. And then 2 times the sum is 2 times the entire x plus 3. C, the quotient of 39 and twice a number. The quotient of means divide. First divided by second. 39 divided by twice a number. 39 divided by 2x. And that is it for this primarily review, but then we did advance a little bit from where we left off last time topic.